So nucleophilic addition reaction. So you can see here what we are doing, nucleophile addition reaction. That means we are adding the nucleophile to the carbonyl group. Okay. So the most characteristic reaction for the aldehydes and ketones is nucleophilic addition. Why? If you see the aldehydes and ketones, what is the common thing in the aldehydes and ketones? What do you find the common thing in aldehydes and ketones? Tell me, what is the common thing that you can find in the aldehydes and ketones?
Carboxyl group.
Yeah. So there is a C double bond O. If it is attached to the hydrogen, we call it as aldehydes. The same C double bond O, if it is attached to two alkyl groups, we call it as ketones. So here C double bond O is the common thing that is present for both the aldehydes and ketones. And if you see here, the carbon and the oxygen, they are bound with a double bond. And we know the oxygen is electronegative atom and the carbon is positive. So the oxygen try to grab the electrons present in the double bond, and it will turn out to be partially negative, and the carbon will turn out to be partially positive. And if this carbon, which is partially positive, can be attacked by the nucleophile, can easily be attacked by the nucleophile. So a nucleophile can easily attach to this carbon. So that's why these reactions are called as nucleophilic addition reaction. You understood? What is the main reason in which the aldehydes and ketones are seeing the nucleophilic addition? Understood? So just remember, this reaction involves the addition of the nucleophile to the carbon-oxygen double bond. For suppose you take a aldehyde, or C double bond O hydrogen. And when there is a nucleophile, let's say the nucleophile attached to hydrogen, and this is an irreversible reaction. So the carbon is added with the nucleophile. You see here. So that is the reason why we are calling this as a nucleophilic addition reaction. So because of this double bond, where the electrons will shift to the oxygen and it will turn out to be partially negative and attacked by the hydrogen, and this carbon will partially turn out to be the positive. And here the nucleophiles loves the positive charge. So they will come and attack this carbon. Understood? So just know this. You need to know two things. One is electrophilic carbonyl carbon. So what is this electrophilic carbonyl carbon? This is the carbon atom in the carbonyl group which is seeking for the electrons, and it is having the sp2 hybridization. Okay, so just know this. So if you see in this carbon double bond oxygen, so this carbon which is seeking for the electrons, because we know this carbon is positive charge, so it is having the electron deficiency. So it is seeking for the electrons. Understood? So just know this, this electrophilic carbonyl atom, it is the sp2 hybridized, it will show, and it is seeking for the electrons. Next one, you need to know another thing, that is accessibility to nucleophilic attack. So what is this accessibility for nucleophilic attack? So we know that what is this structure? This is a planar structure, yes or no? So know this, this is a planar structure. So due to the planar structure, whatever the carbonyl group is there, in that carbonyl group, the carbon is relatively unhindered. That means, what is meaning of hindrance? What is meaning of hindrance? Shrikar, tell me, what is meaning of hindrance? Mandara, what is meaning of hindrance? I've told you this many times. We have also discussed in alloalkanes and alloarenes. What is meaning of hindrance? Sharan?
Yeah.
What is meaning of hindrance? Nitya?
Sir, when there is a bulky group or
Yeah.
more electronegative group, it would allow the nucleophile to attach.
Yes. So when there is a carbon which is surrounded with the bulky groups, when this is surrounded with the bulky groups, it is very difficult for any atom to approach to the center carbon. So that we call it as the hindrance effect. But if you see here, the accessibility for nucleophilic attack can only be possible when it is unhindered. Okay, when it is unhindered. Yes or no? If it is surrounded with a bulky group, what happens? The nucleophile to approach this carbonyl carbon is very difficult. Yes or no? Because this is surrounded with the bulky groups. They are obstructing here. So this is very difficult for the nucleophile to come and approach this carbon. So we need accessibility for nucleophilic attack is mainly depends on whether it is showing hindrance effect or it is not showing. Okay. So as the nucleophile is planar structure and it is unhindered and it is very open for the nucleophile to come and attack the double bonds. Okay. So unhindered and open. So the double bonds can be easily attacked by the nucleophile. Understood? Ray, understood, Shikhar? రే శ్రీకర్ నువ్వు ఉన్నావా క్లాస్ లో
Yes, sir, I'm there.
ఎరా నోరు ఓపెన్ చేయట్లేదు
Sir, I just got a call from mom, so then I went. Sorry, sir.
Okay. So this is unhindered and open. Okay. Because of this, the double bond can easily be attacked by the nucleophile. Understood? So it is very easier for the nucleophile to approach and react with the carbonyl group. So that is the two things you need to consider for this reaction to happen. Apart from that, you should also look about the oxygen. Okay. So what do we need to know about the oxygen? Because the carbon is attached to oxygen with a double bond. So there should be electronegativity of the oxygen. Electronegativity of oxygen. So why do we see the electronegativity of oxygen? First, suppose the carbon double bond O, if the oxygen is not electronegative, it cannot pull the electrons towards it. And if it cannot pull the electrons towards it, it cannot become partially negative and the carbon cannot become partially positive. If the carbon is not positive, then the nucleophile attack on the carbon is very difficult. Because we know the nucleophile loves the positive charge. And the carbon present here should be more positive, then only the nucleophile can come and attack. But if the carbon is not positive, then it's very difficult for the nucleophile to attack this carbon. So that's why the electronegativity of oxygen is very, very important. Apart from that, the bond polarization. So what is bond polarization? Whatever the carbon and oxygen are there, they leads to polarization of the double bond present between them. That means, so one electron will shift to the oxygen. So that will turn out to be partially positive on the carbon and oxygen will be partially negative. So this conversion of the neutral charges into partially positive and negative charges over the bond in the carbonyl group is called as polarization. So this polarization makes the carbon atom partially positive and it is very susceptible for the nucleophilic attack. Is that clear? So these are the four important factors you need to understand. See, why I'm stressing on this very much is there are questions on this. I'll show you at the end. If you know those questions very well, you can understand various other factors like how does the resonance is affecting, how does the ketone and aldehydes can be differentiated. So why they show difference in the reactions. You will all clearly understand if you understand these four factors. Is that clear?
Yes, sir.
Okay.
Yes.
So see here, how does the mechanism will happen? So the reactivity of the carbonyl group arises from the electronegativity of the oxygen atom and the resulting polarization of the carbon-oxygen double bond. So for whatever I discussed here, okay? So electronegativity of the oxygen and bond polarization. That is very important here, okay? So the oxygen atom should be electronegative so that it can create the polarization in the carbon-oxygen bond. Yes or no? So carbon-oxygen is there. If the oxygen is electronegative, then only it can able to pull the electrons over it. So it can turn out to be negative charge and the carbon can be turned out to be positive charge. Then only the nucleophile can come and attack here. So that's a very important thing. Okay. So the polarization is mainly depend on the oxygen, whether it can create the polarization in the carbonyl carbon oxygen double bond or not. Next one is the structural features. It is showing the planar geometry, okay, and it is relatively unhindered, okay. So those are the two factors that we saw. So one is on the oxygen, so whether it is electronegative or not. If it is electronegative, then it can create the bond polarization, so partially positive, partially negative. Apart from that, in order to approach this carbon, it should be accessible. That means it should not be hindered. So it should be unhindered and open for the nucleophile to approach this carbon. And then electrophilic carbonyl carbon. It should be sp2 hybridized and it should show the planar structure. Understood? So know those things. So the electrophilic carbonyl carbon atom is sp2 hybridized and planar, leaving it relatively unhindered and open to attack from either side of the double bond. So the nucleophile can attack over this way or this way on the either side, from the top or from the bottom. Okay, so there will be two ways. So nucleophile attacks the carbonyl group perpendicularly. Remember this is very important. It's a perpendicularly. So that whatever the sp2 is there, it will finally convert into the sp3 hybridization. Whatever the C double bond O is there, it will convert into C nucleophile OH. So we know if it is a double bond, it is sp2 hybridized. If it is all single bonds, it is a sp3 hybridization. So that's how a double bond sp2 will converts into single bond sp3. Is that clear? So how does the reaction will happen? It will take place in two steps. One is the attack of the nucleophile. And the step two is protonation. Whatever the single double bond converted into the single bond, it should be protonated. So the step two is protonation. Okay. So we'll see how does this will happen. So let's see attack of the nucleophile. Let's take an example, aldehyde R1. Okay, let's take a ketone R double bond O. Okay, I'm taking either the aldehyde or ketone. So here I'm taking the ketone. So C attached to two alkyl groups and it is having carbonyl carbonyl group. So this is a ketone. In place of R, if it is hydrogen, then we call it as aldehydes. Okay. Which will be attacked by a nucleophile. And this reaction, remember, it is a very slow reaction. It's not a fast reaction, it's a very slow. So that will be converted into C R R O minus. So all are in same plane, but the nucleophile will attack perpendicularly. So if the nucleophile attacks from the up direction, or it could also attack from the low direction, so that's why there will be chance for another compound to form. So that will be C. Just write all up directions. If you see here, still I maintained O minus here. So that's the second step. We'll do the protonation, and whatever the negative charge is there, we'll neutralize to hydroxyl group. Okay. So this is the step number 1, attack of nucleophile. The nucleophile may attack from above the double bond or below the double bond. It can be from above the plane or below the plane. Okay. Of the carbonyl carbon. So you can see here, it can attack from the above or it can attack from the below. And here the carbon is partially positive and the oxygen is partially negative. So attack of nucleophile from above the plane of sp2 hybridized carbon atom, or it can also happen through below the plane. So it can form two intermediates. One is the tetrahedral intermediate 1, or it could be tetrahedral intermediate 2. Okay, if it is attacked from below the plane. So we'll get two different kinds of compounds if the attack happens from the above the plane or below the plane. And finally, whatever the sp2 is there, it will convert into the sp3. A tetra alkoxide intermediate will be formed. Either the nucleophile is above the plane or below the plane. And the step number 2 is protonation. Okay, so what happens here? Whatever this alkoxide ion is there, this alkoxide ion will be protonated. That means a proton will come and join here. Okay, so that result in formation of a compound. Okay, so see here. Let's compare the difference between the aldehydes and ketones. Aldehydes are more reactive than the ketones in nucleophilic addition reaction. So what are the main reasons for that? One is the electronic factors, the steric factors, and the resonance. So these are the three factors which will influence aldehydes to be more reactive than the ketones. Okay, so let's see each of them one by one. So first one is the electronic factors. So electronically, aldehydes are more reactive than the ketones because two alkyl groups reduce the electrophility of the carbonyl carbon more effective in ketones than aldehydes. So let's make it simple. First, suppose let's take an aldehyde and ketone. C double bond O R and H. C double bond O R and R. So this is the aldehyde and this is the ketone. If you see here, here there is a alkyl group is present. Yes or no? Is a alkyl group. And we know that the alkyl group contains more electrons. Yes or no? And if you see on the ketones, there are two alkyl groups are present. That means they can give more electrons to the carbon here. Okay. So because of that, it will show the positive inductive effect. They will show positive I effect. Okay. So between the carbon, on the carbon. So because of that, ketones will decrease the reactivity compared to the aldehydes. Because, so what is the main reason for the nucleophile to attack the carbon? The main reason is the carbon containing positive charge. So that nucleophile loves the positive charge and it will attack the carbon. But if you see here alkyl group is present which contains more number of electrons. So this alkyl group can push the electrons to the carbon. Okay, so whatever the bond electrons are there, it will push those electrons towards the carbon. When electrons are getting towards the carbon, what happened? The positive charge of the carbon decreases. And instead of slightly positive, it will turn out to be slightly negative. Or whatever the positivity is there, that will slightly decrease. But if you see here, there are two alkyl groups are present. That means it will be whatever the positive charge is there. Here, this R group will push the electrons towards the carbon, and this R group will push the electrons towards the carbon, and this positive charge will further reduce and it will completely turn out to be negative. So the more effect is seen on this carbon compared to this carbon, because here only one alkyl group is present, whereas here two alkyl groups are present. Do you guys get my point here? What I'm trying to say?
Sir, could you please?
So could you repeat it?
Okay. What about you, Banu?
Yes, sir.
You understood?
Yes, sir.
Okay. So see here, there is a carbon. It should be attacked with a nucleophile. When can it be attacked? When it contains the positive charge. Yes or no? Nucleophile loves the positive charge. So the carbon should be partially positive, then only this can happen. But what we are doing here, I kept here an alkyl group. Alkyl group contains number of electrons. So those electrons, they are trying to push towards this carbon, this star carbon. So because of that, whatever the positive charge is there, it is losing its positive charge. So this positive charge, it is losing. It is decreasing. The positive charge here, it's a decreasing. And this positive charge decreasing is much happening on ketones because there are two alkyl groups are present and both are trying to decrease that positive charge on this carbon. And so that this carbon will be much more negative compared to this. So this is positive and this is negative. Because of that, these aldehydes will show more reactivity than the ketones because of this positive inductive effect. Understood, Sharon?
Yes, sir.
Okay. So what is the positive inductive effect? What is positive inductive effect? So from this you can define what is positive inductive effect. Banu, can you try what is positive inductive effect? Can you tell?
Yes, sir. 1 second. So, an atom that contributes electron to form a bond is called positive inductive effect.
That's okay. Okay, I'll explain that. Okay. Yeah, whatever you said is correct.
Okay.
But what is the reason behind it? Is the positive? You said, okay, an atom that is attached to another atom, that's creating a bond because of the positive effect. But how is it
Yeah.
happening? For suppose I told you, aldehydes are able to make the reaction much more compared to the ketones because due to presence of certain atoms, the carbon here losing the capability to make a bond. Whereas in the aldehydes, they are able to make the bond here. So that's a positive effect. So positive effect, inductive effect of alkyl groups decrease the amount on carbon in ketones, hence the reactivity decreases. I told you what's the reason. Okay, I'll explain you in detail. Just let's see.
Okay,
Okay.
sir.
Yeah. So next one. So carbonyl carbon of aldehydes is more electrophilic than ketones. Therefore, more reactivity towards the nucleophilic addition reactions. Okay, I'll explain you in detail. Let's see an example there. So next one, you see also the steric factor. So if you increase the steric entrance, that will decrease the stability of the atom. Whatever the intermediate that is formed, the stability decreases, so the reactivity decreases. That means the atoms which are less steric entrance or which are unhindered, they will show more reactivity compared to the atoms which are having less steric entrance. I'll explain this in detail. So let's see example. Okay. First, suppose let's compare between the aldehydes and ketones. Let me take the aldehyde and let me take the ketone on my right side. So let's see various factors, how they are influencing these aldehydes and ketones. Okay. So first of all, what is the common thing in the aldehyde and ketone? There is a C double bond O. Yes or no? So both are containing this carbonyl group. So both are having this carbonyl group. And if you see here, the carbonyl group, already because of the oxygen, the carbon slightly got the negative charge. Sorry, because of the, let's see, carbon double bond oxygen, as the oxygen is trying to pull the electrons towards it, it got slightly positive on the carbon and slightly negative on the oxygen. Tell me, is this clear? There is a double bond between the carbon and oxygen is trying to pull those electrons towards it. As it gained the electrons, it is slightly negative, and the carbon is slightly positive. Is that clear?
Yes.
Okay, so let's see next. Let's see the structural difference between them. If you see the aldehydes, aldehydes contain the carbonyl carbon that is attached to one alkyl group, double bond oxygen and hydrogen. And if you see the ketones, it is also having the carbonyl carbon attached to oxygen with a double bond. But there are two alkyl groups are there. It could be alkyl group or aryl group. It could be a chain or it could be a ring. Aryl means ring, alkyl means chain. So that's the structure. Let's see the reactivity based on this structure. If you see the aldehydes, they are generally more reactive than the ketones towards the nucleophilic addition reaction. I told you. Okay. So the reactivity for the aldehydes is generally more compared to the ketones. There are two main factors for this: more reactive, and this is less reactive. For this, there are two reasons are involved. One is the electronic effect. What is this electronic effect? If you see the carbonyl carbon of the aldehydes, they are having greater partial positive compared to the ketones. I told you what is the reason for that. Okay, here the partially positive is more compared to the partially positiveness of this ketone, because here there is a presence of this alkyl group. That alkyl group is pushing the electrons towards the carbon. Okay, like that there are two alkyl groups are present. They both are pushing the electrons towards the carbon. So the positive charge which is present more, it is decreased. Whereas here it is only one alkyl group, so it is not decreased much. So that is the reason electronic effect is more for this carbon compared to this carbon. Okay, so the carbonyl carbon in aldehydes is greater partial positive compared to the ketones. Have you understood this? So greater partial positive, lesser partial positive. Okay, so what is this partial positive? Why it got? Because of the electron donating effect on the carbon. Okay, so it is electron donating R group. So whatever these R groups are there, they are donating the electrons to this carbonyl carbon. Because of that, the positive charge is decreasing. In aldehydes, only one electron donating R is present, so it is not very less. I mean, it is the effect is very less compared to the ketones. Is that clear? So this effect, we call it as inductive effect. Okay, so just know this inductive effect. If you don't know or if you forget, just know inductive effect. So generally the carbonyl carbon is electron deficient. Why? The carbonyl carbon is electron deficient. Why it is electron deficient? Because whatever the electrons present on this carbon, it is taken away by the oxygen. So it is having deficiency. Okay, so it is having less electron density. But due to the presence of alkyl groups, the electron density on this carbon is increasing. If it is only one alkyl group, the electron density is only less increased. But if it is two alkyl groups, the electron density is much more increased. So the negative charge will be more, okay, in the ketones compared to the aldehydes. For suppose it's only having. So if you see here, the negative charge is only 2, whereas here 3, and the partial positive charge is 4. So it is creating net more positive compared to here. Okay, here the positiveness is less, whereas here the positiveness is more. Understood this? So this pushing of electrons by presence of a alkyl group on this carbon, that is called as inductive effect. If you don't understand, just remember now. I'll not explain this inductive effect again. So just know, because of this two alkyl groups attached to the carbonyl carbon, the electron density in the ketones is more compared to the aldehydes. Because of that, the aldehydes are more partially positive compared to the ketones. Okay, so that increasing the reaction in the aldehydes compared to ketones. See, I'm stressing very much because the reactions will be depend on this. If you understand this key point, the critical point of this, you can easily solve many questions. Okay.
Sir, could you just repeat it for once?
Array, see here, ikkada rendu alkyl groups unnara. Okay, there are two alkyl groups are present. So this alkyl group is donating the electrons to the carbon. This alkyl group is donating the electrons to the carbon. So what happens now? The electron density on this carbon increases or not?
Yes, sir.
Okay, whereas here it's only one alkyl group is present and that is donating the electrons, whereas the other one it's hydrogen, so it's not donating electrons, instead it is taking electrons. So the electron density in this case decreases or not?
Yes, sir.
If the electron density decreases, the positive charge will be increases. Yes or no?
Yes, sir.
So if the positive charge increases, then the nucleophilic attack will be easy. Yes or no? Because nucleophiles will love the positive charge.
Yes, sir.
Yeah, that's the reason. So this entire thing is called the inductive effect. Is it clear?
Yes, sir. Got it.
Yeah. So just understand. Okay. Next one, the steric effect. Should I write or you understood? I don't need to write anything. If you want, I'll
So can
write the
you write?
explanation.
So can you write one some form of explanation?
Okay, let me write it. Okay, so there are alkyl groups are present. So these alkyl groups push electron density towards carbonyl group. That happens through inductive effect. Okay, so because of this, because of this, see less positive, or you can also call this as less electrophilic. Okay, this also mean less electrophilic. So the nucleophiles are less attracted to carbonyl carbon. You can also call it as carbonyl center as well. Okay. See, because of this, nucleophiles are less attracted to carbonyl carbon. Okay. In order to attach or add this nucleophile, we need activation energy. Okay. See, you are trying to attach the nucleophile to this carbon, but the nucleophile can only attach to this carbon when it is positive charge. But in these conditions, in the ketones, the positive charge is decreased. So in order to attach this nucleophile to the carbon, you need to put or invest certain amount of energy. So that energy we call it as uh, nucleophilic addition activation energy, something like that. Okay. So just know this. So you need to invest energy more for the ketones compared to aldehydes. So the aldehydes are more reactive compared to the ketones. I'm not writing that. I'm just stopped here. So understood? I'm not. How do you compare the reactivity between the aldehydes and ketones?
Understood, sir.
So this
Yes,
is one factor. Okay, inductive effect. The second factor is the steric effect. So what is steric effect? I told you the steric hindrance. Okay. So if you see here, aldehydes, they are C double bond O R H. And you see the ketones, C double bond O R and R. So which one is having more steric hindrance here? Which one is surrounded with the bulkier groups here?
Ketone.
Ketones, right? So ketones are surrounded with the two alkyl groups. It could be alkyl groups or aryl groups. Okay, so it is having more steric crowding effect compared to the aldehydes. Okay, so the crowd is more in the ketones compared to aldehydes. So the nucleophile approach to this carbon is very difficult in the ketones, whereas the nucleophile approach in the aldehydes is easy. So nucleophile approach easy, nucleophile approach is difficult. Okay, so because of that, the ketones will show the less reactivity compared to the aldehydes. Understood?
Yes,
So that
sir.
is called the steric hindrance. So just to quickly see what is the difference between the aldehydes and ketones. So aldehydes, they are one group is a hydrogen atom, whereas here two groups are alkyl groups. So central carbon product formed is less crowded, whereas the central carbon product formed is more crowded. That's a steric hindrance. Okay, so you can see here in this picture, it's a very clear. So formaldehyde is more reactive in aldehydes due to less steric hindrance. You can see here. Formaldehyde, both are hydrogens. Whereas this one, it is having one R group. This one is having one R group. Whereas here in ketones, it is having more R groups. So the reactivity will be like this. So this is more reactive than this, than this. Okay, so this is the aldehydes. In the aldehydes itself, the formaldehyde is more reactive, and then aldehydes are reactive. Ketones are less reactive because of the steric hindrance. Next one, ketones product is more stable. In aldehydes, product is more stable. In ketones, it is less stable. Okay, that's how formation of the product is favored at the equilibrium, whereas here the small concentration of the product will be formed at the equilibrium. Instead of, see, product, reactants should form the products when you see at the equilibrium. So after the reaction has happened, we see more products in the reaction compared to the reactants. Then we say the reaction is very good for product formation. Okay, if the reactants are more after the reaction compared to the products, then we say it is very less reactive. So the reactants were left over compared to the products, and very few products were formed. Okay, so next one is the resonance effect. What is resonance effect? So if the electron density increases on the carbon atom of the carbonyl group due to the resonance, then the reactivity of the aldehydes ketones towards the nucleophilic addition reaction decreases. That means the aryl group stabilize the reactants by resonance, cause a net deactivation effect of the reactants. Okay, what is that? The aryl group stabilizes the reactant by resonance. That means the stabilization occur through electron delocalization. We saw, for suppose you take the benzene, what happens here? The electrons will keep on moving. They keep on shuffling. Because of that, what happened? There is an electron delocalization. And when there is an electron delocalization, what happened? It will give more stability. And if the atoms or molecules are more stable, then they are less reactive. We know that's a basic funda of the chemistry. Yes or no? So why does the chemical reactions happens? To become unstable to stable. Yes or no? But if the reactant is itself more stable, then why would it want to form the reaction if it is already stable? Okay, if the more stability, then it will be showing less reactivity. If it is very unstable, then it will show more reaction. Okay, so if the electron delocalization, if resonance is more, then the electron delocalization will be more. Due to that, there will be more stability. Because of that, there will be less stability. Understood this? So that will cause a net deactivation effect of the reactants. That means whatever the reactants are there, they will not participate in the reaction. They will just sit quiet without involving in the reaction. So let's see how much you understood in today's class. So we'll see the questions. So the order of the reactivity of the following compounds for nucleophilic addition reaction is. So tell me.
So propanol will be more reactive.
Okay, don't tell me the reason. What about the others? Is it this one or this one? Is it one or two? Come on, guys. Tell me what is the answer. Sharon, what is the answer? One or two?
Sir, I think two.
Huh? Sharon,
So
కొంచెం గట్టిగా చెప్పు.
Sir, I think two.
Okay. What about you, Banu?
So second one, sir.
Can you tell me what is the reason? Why the second one is the answer? Yes, okay. Tell me.
Sir, is it cause of inductive effect?
Not a inductive effect. Yeah, you can take the inductive effect, but the main reason,
Electronic effects.
see, these are two things. One is the inductive effect as well as the benzaldehyde. Benzaldehyde means it will show more resonance. Yes or no? So when the resonance is more, the stability is more. When the stability is more, the reaction decreases. So that is one way. Second way is benzaldehyde. It is a bulkier group. It contains more electron density. So because of this benzaldehyde, it will give more electron density to the carbonyl carbon. Then it will, from the positive charge, it will slightly decrease to less partial positive. Whereas in the case of propanol, it is different. So the answer 1 is correct. Understood? Is this clear?
Yes, sir.
Okay, so try this one.
Sir, option C.
So Nitya says option B. Okay, what about the others?
No, sir, C.
Option C. Okay, what about the others?
So C.
One second, guys. So Mandara, your answer is C. What about the others? Come on, tell me, what about the others?
Sir, I don't know, sir.
Okay, fine, no problem. Sharan, what about you? Choose any answer.
Sir, sir, I said also C.
Okay. Okay, let's see one by one. First one. So here we are having the formaldehyde. So this is a formaldehyde and this is a, what is this? This is acetaldehyde. So see here, what happened here? The electron deficiency on the carbon of the carbonyl group is increased or decreased in this case and in this case. Electron deficiency increase, yes or no? Because both are just a small groups, right? So electron deficiency increases. Okay, so if the electron deficiency increases, what happens to the reactivity? So reactivity increases. That's great. So both will show higher reactivity towards the nucleophilic reaction compared to the benzaldehyde. Okay, so let's see the next one, the option D. Let's come back to C later. First, we'll see the D. So here there is a NO2 group is present. There is a benzene and there is an aldehyde. And we know See, this is the benzene and CHO. This is the benzaldehyde. Compared to benzaldehyde, will it be having more or less? The reactivity. If it is more, what could be the reason? Why you guys didn't choose the option D? Because this is also somewhat near to the benzaldehyde. So why you didn't choose the option D? If I don't give this option, because here both two benzene groups are there, so this will be, and it's a ketone. So we know this will be the answer. But why? If I don't give the option C, what would be the answer out of A, B, and D? See here, NO2 group is present. And we know NO2 group is a strong electron withdrawing group. Just remember, NO2 is a very strong electron withdrawing group. So because of this, it will create a negative M effect, negative mesomer effect. Okay, so that will create a more electron deficiency on our carbon. So it will be more reactive than the benzaldehyde. And this is the easy answer. We know there is a two carbonyl groups are attached. So there will be positive M effect. So this will be giving the electrons, this will be giving the electrons. So that will create the less positivity on this carbon. Okay, so it will be very less reactive. So this will be the answer. Is that clear why the option C is correct? Any doubts? So next one, see this. So arrange the following compounds in the order of their boiling point. So which one is the order? It should be this or this. You should consider whether it's a polar or non-polar compounds here. So tell me, is option 1 or option 2?
Sir, option 1.
Option 1. How do you tell by this? This is a
No, sir.
ketone. So obviously the aldehydes are more.
No, yeah, the last one is alcohol, right? So then alcohol is more than ketone, and
What is the reason for alcohol is more than aldehyde?
that I don't know, but this point I know. Ketones and aldehydes are lower than alcohol. So last one is NaCl.
Okay. Okay. So see here, what is this? This is a alcohol. And what is this? Aldehyde. And what is this? Ketone. And what is this? Alkanes. Okay. So let's see what is the reactivity order. Before that, there's a intermolecular hydrogen bonding is present in alcohols. Okay. Do you know that intermolecular hydrogen bonding that happens in alcohols? So one alcohol will attach to the other alcohol with the help of hydrogen bonds. So there is a intermolecular hydrogen bonding. So because of this intermolecular hydrogen bonding, okay, the boiling point is maximum here. Why? The polar compounds has more boiling point than the non-polar. And we know those which could be able to make the hydrogen bonding, they are the polar compounds. Okay. And if you see the aldehydes, so that's the reason why it will be the maximum. And if you see the aldehydes, these are more polar than the ether. I told you there are many reasons. We have explained what is the difference between the ketones and aldehydes. We have seen many factors. So obviously I can give. Let's see between the alkanes and the ketones and aldehydes. Alkane, it is a non-polar. It is the strongest polar is alcohol. Next one is aldehyde, then the ketones. Whereas alkane is completely non-polar in nature. So because of that, it is having the lowest boiling point. And remember, those which are having intermolecular hydrogen bonding, those which are polar, they will be having maximum boiling points. So all these comes under the polar. Okay. So just remember this. So this is a polar and this is a non-polar. Because of that, it's having lowest boiling point, and because of intermolecular hydrogen bonding and maximum polarity seen in the alcohol, so this will be the highest boiling point. Is that clear?
Yes, sir.
Yes, sir.
Yes.
Saran?
Yes, sir.
Okay. So next one, tell me what is the answer? If you see here, one thing is unique. So A, C, and D, all these three are aldehydes. And here option B is ketone. So how do you approach when you don't know the question? So just go with the options and try to do elimination. So this is a ketone. And these three are aldehydes. So I know the reactivity order is ketones is lesser than the aldehydes. So I can remove this my option. So just cancel it out. Now I have a option three. Three options are there. So now I need to go with the options three options. So see here, what is this group? This is an alkyl group, yes or no? So that alkyl group will contribute more electrons to the resonance, and that also contributes more electron to the carbon. So the positivity over the carbon decreases because this is a bulkier group. It can donate the electrons. And here the methyl group is also giving the electrons instead of taking. Yes or no? For suppose if you take the nitrogen dioxide, the NO2 group, it will take the electrons from the benzene ring. For suppose let's see there is a negative charge, and here positive charge is present, and here positive is there. If I give the negative charge to this A, then the positivity decreases. If I give the electrons to the B, then the positivity decreases. But which one is should I give? Should I give to A or B? If you compare here, the B has a more capability to than the A. So B will try to pull more electrons towards it than A. So as the electrons are moving towards the B, the electrons moving towards the A is decreases. So the positive charge will remain intact here. So this will not be my option. And if you see, the benzaldehyde can easily give. So this will not be my option. Hence the option D is correct. Is that clear? Why the option D is an answer?
Yes.
I can easily eliminate this because this will give the electrons. So I eliminated. So now out of these two, which should be the answer? I'll see the additional group that is present here. The methyl group will also donate the electrons. Why? The carbon is attached with hydrogens. Here, all the hydrogens will give the electrons to the carbon. So there is a negative charge more on this carbon. So it will also donate the electrons. Whereas here, nitrogen dioxide, it will try to take the electrons from the benzene ring. Hence the reactivity increases here. So this will be my option. Is that clear?
Yes.
Yes, sir.
Yes, sir.
So next one, see this. Come on, very simple one. So just differentiate which one are ketones and which one are aldehydes. So we know this is a ketone, so I can eliminate this option. This is also ketone, I can eliminate the option. So now C, A, and D, which one is having bulkier group? Option A is
D.
having bulkier group or D?
D.
D.
C double bond O, H, and here only CS3. Whereas here C double bond OH, and here there is a CH2, CH3. So there's a big bulkier group here. So this is also not my option. So answer is A. Understood? D is
Yes.
not the answer. Answer is A. If you are thinking the answer is D. Okay, next one. See this one. So which one is correct? Come on, quickly.
Sir, option D.
Nitya says option D. What about others?
So mine too option
Hmm?
D, sir, D.
Okay, Sharon, you are also saying the option is D.
Sir, even I think it's D.
Are you sure? What about you, Banu and Shrikar?
So, so I think it's D only, sir.
You know, there is a saying. What is that? When a sheep, if one sheep falls in the well, all the other sheep will just jump into the well.
So maybe C, I think.
Okay, so one is saying C. What about the Shrikar? You're the last one.
Yes, sir.
చెప్పరా నువ్వు ఏదో ఒక ఆన్సర్ చెప్పేసా ఏముంది
Sir, I guess it's A.
చచ్చిపో The answer is C.
Oh.
So what happens here? We know aldehydes. Aldehydes are more reactive than the ketones. Okay. And next one, that's a one case. Second one, aliphatic aldehydes are more reactive than the aromatic aldehydes. So within the aldehydes, aliphatic are more, the one with the chain are more reactive than the aromatic, because aromatic are bulkier and they will show the resonance and they will show much more entrance compared to the aliphatic. So that's why the aromatic reaction will be very less. So aromatic aldehydes. So now tell me at least, what will be the answer? See here, this is aromatic. So let's take out. So first one, let's come from here. So what is this? Formaldehyde. It's not a ketone. If you think this is a ketone. So there's a double bond O hydrogen and there's a hydrogen. So I told you formaldehyde, within the aldehydes, the formaldehyde is much more reactive than any other aldehyde. So this is the answer. And you see here, this is a aliphatic aldehyde. So this will be the next. And if you see here, aromatic, within the aldehydes, aliphatic are greater than the aromatic. So this is also correct. And if you see here, this is the ketone. And we know compared to aldehydes, ketones are stronger. And within the ketones, aromatic, aliphatic. Aromatic is the least. So this is the aromatic ketone. This is the aliphatic ketone. And this is the aromatic aldehyde. And this is the aliphatic aldehyde. And this is the formaldehyde, which will be the containing both the sides hydrogen. Understood? Is that clear?
Yes, sir.
Yes, sir.
Yeah, the final one. Come on, answer this. See, I'll just give a clue here. If you think what is this fluorine and chlorine. Okay. So tell me which one is more electronegative, fluorine or chlorine? Which one is more electronegative? Is the fluorine is more electronegative or chlorine?
Fluorine, sir.
Fluorine is more electronegative than chlorine. Fluorine is the strongest electronegative atom in the entire chemistry. So I told you, if it is more electronegative, that means it will pull out the more electrons towards it. And it will create the electron deficiency on the carbonyl compound. And then the chlorine will do. Now try it. So what will be the answer? Tell me which is the option. Do one thing, don't tell outside, just send me directly the message. What will be the answer? Direct message. I already told you the answer easily. Come on, quickly. I got a message from Nitya. Wow. Okay. Yeah, Sharon, yours is also correct. Mandara, your answer is also correct. Come on, Shikar. Manu, what about you? Hey, Shikar,
Yes, sir.
what's the answer?
B.
Okay, okay. What about you, Banu?
So I don't know, sir.
C. Okay, the answer is B. Everyone correct? See what happened here? There is a carbon which is attached with fluorine, and there's a fluorine. And here there is a carbon which is double bond O and hydrogen. Okay. If you see here, this fluorine is pulling out the electrons towards this carbon. This fluorine is pulling out the electrons from the carbon. This fluorine is also pulling out the electrons. So all are becoming negative. And this carbon is becoming strongly positive charge. Okay. So because of that, it is also trying to pull the electrons from the carbon, which is a carbonyl carbon. So now this star carbon is becoming much more positive. And as it is much more positive, this will be the greatest reactivity. The same happens with the chlorine, but the effect of fluorine is much more stronger than the chlorine. So that's why first will be the W, this one, next will be the chlorine, and next it will be Y. And next it will be Z, because Y is the aldehyde and the Z will be the ketone. So aldehyde shows more than the ketone. So the answer is B. Understood? Banu? Why the answer is B? Okay, then we'll just wind here. So any doubts? Am I audible?
Yes,
Yes,
sir.
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 Then why you are everyone keeping mute? Any doubts?
No, sir.
No, sir.
Yes, sir.
Okay. Okay then. Good night. So Banu,
Thank
just
you.
stay in the class.
Yeah, yes, sir.
Thank you, sir.
Yeah. Thank you guys. Good night. Take care.
Thank you, sir.
Sir,
Chapra.
can I submit record next week?
Okay.
Thank you, sir.